All right, so we want to take some time today. We want to talk about the DHCP network configuration option. There is a lot of discussion in the world about, in the NDI world, about which is the best way or the preferred way or the ideal way to set up NDI systems. And for a long time, you know, BirdDog, but NDI in general, didn't really want to talk about the networking piece. Now, it wasn't that we were shying away from it, but it was that we didn't want to scare anybody away from buying the NDI protocol. But as time went along, and especially here at the support desk, we learned that it's not that people would be scared away. They actually just want to know how to do it. And that became very prevalent very quickly for us when we got talking with customers who were frustrated with, hey, I was sold a product, the instructions were just plug it in and it should work, and when I plugged it in, it didn't just work. It keeps falling back to 192.168.100 for some reason. Like, why is that? Or it would never take an IP address, or I would set a static IP address and it would disappear from my network. Well, what's the story there? Or, you know, when I plug it into my Wi-Fi system, you know, enabled network, it would kind of work, but it would kind of drop frames. Like, what's going on with that? And we were very vague about why you needed to do things a certain way. And so people seem to appreciate more often this conversation about, well, there is a better way to do it. Would you like to know? And they would say, yeah. And we would set them up with proper hardware. We would set them up with a proper configuration that we considered proper. And over some time, over the first 2 years of my employment, and here's a little behind the scenes here at BirdDog, is I was hired on not because I had any production experience. I was hired on because I was a network administrator. I had run a network for a mid-sized college university, currently a university, a mid-sized school that was for higher education, that had multiple networks, multiple governances, okay? And I had learned a whole lot in the 3.5, 4 years I did that job for them. And so I came on with some networking experience, but not a ton of broadcasting experience. But part of the conversation, a lot of the questions that we were getting from customers at the time were, we're having trouble with the network piece. And if you take a step back and you look at the clientele that are BirdDog clients, the majority of them are broadcast people. They're people that are using cameras on a daily basis, that are used to colorizing these cameras, that are used to understanding exposure and white balance. They're talking about things that are camera-related issues. But when it came time to talk about network, it was completely outside of their wheelhouse. They didn't have experience with that. And so really what they needed was the ability to set things up in a general configuration and know that they were going to get consistent results. Now, NDI is a bit of a double-edged sword, because you can set things up in a certain configuration for a certain amount of data on your network. But when you start adding sources or decoders or computers that are interacting with those sources, all of a sudden the network requirements change. And so you need to be able to understand what's changing and why it's changing. Maybe we're starting to get drop frames. We set up everything. We're monitoring things in Studio Monitor, but then we fire up Wirecast or vMix, or we put our TriCaster on there. Or we really like the performance of OBS with our 3 cameras and a keyboard, and so we invest in 2 more nicer cameras. We get 4K cameras. We put those on the network, and all of a sudden, our HD cameras that were working just fine for months on end are now dropping frames. Well, what's the deal with that? Well, the network is really the problem, and you need to understand clearly what is happening on a network level when we're doing NDI workflows. And so we really shot ourselves in the foot. And I mean, I'll be the first to claim that we didn't do it right. We should have spent more time considering network education for the NDI realm, because the primary consumers were not going to be YouTubers and streamers. They were going to be broadcast people that were buying these and putting these in large installations. Perhaps it was a customer that was considering NDI for boardrooms and for conference rooms and for hotel, conference rooms and rentable spaces. Perhaps it was classrooms for lectures or big installations where you want to record things or utilize streaming for the COVID era. All of those sorts of environments are different and are going to require different networking infrastructures. And so we really need to boil it down to the basics. And over the first couple of years, the support department, which I'm proud to say, developed a list of network recommendations. Hey, if you want to have a better result, try this. Okay? And my team uses those probably on a weekly basis now with most customers, saying, hey, we know that your network is having an issue. We recommend trying this. And that seems to serve us pretty well. So we have a list. We have a running list, which I'll go over, but I'll kind of demonstrate this as the discussion unfolds as to how to configure a DHCP service, your network, and why we recommend these things over other configurations. And in particular, my discussion from the previous video about static networks, why I would recommend DHCP over static, why it might work better, make your life easier, and be easier for the customer. It also has some niceties for the support department. Not that that should be a driving factor, but if you require support, it will also help you in that regard. So it's kind of has a lot of feet in multiple camps, if you will. Okay, so why DHCP, and what is it? I mean, why would I even consider this? Well, DHCP is essentially a service that runs within the network configuration that helps delegate but identify network nodes throughout your installation. Okay, so I've got 3 cameras and a keyboard, and I plug them into a DHCP system. Well, out of the box for BirdDog products, everything is set to DHCP. It's set to acquire an IP address from your system and begin to output NDI onto the network. That's the default position. For those of you who are keeping score at home, it's also in a unicast configuration. Generally, TCP is where we are at time of recording here in 2023. TCP unicast is the way that we generally have it out of the box, because if you're doing more sophisticated installations, you would need to go in and customize that. So DHCP is the thing that will automatically issue you a IP address. It will, behind the scenes, register where that device is. So I assigned an IP address to that MAC address, and that's going out, port 12 on this switch, which is connected to this switch up the chain, or is connected into the trunk, and here's the path. Behind the scenes, the DHCP server is learning all of that information. So when you plug in your device, the BirdDog device sends out a broadcast request saying, here I am, here's my MAC address, I need an IP address to operate on this network, and then the network will issue an IP address. Now, common, current day networks will be pretty smart, and they'll remember that MAC address and remember what IP address it issued it. And as long as you're not having high amounts of traffic, lots of requests for IP addressing, as long as that network stays relatively quiet, that IP address will remain the same all the time. Generally, in a network that doesn't have a lot of IP requests, okay, so let's say a Wi-Fi network, right? You have a guest Wi-Fi network. People are showing up with their cell phones and they're connecting to your Wi-Fi, and it gets an IP address. Well, that customer comes and goes. Maybe they come here every 6 months, or they go to the coffee shop every few weeks. Well, they don't need the same IP address every time they join, because lots of customers are coming in, attaching to the Wi-Fi, using it a little bit, and then leaving the coffee shop and disconnecting. That IP address was assigned to that MAC address, but the next customer comes in, and the next customer, and the next customer. Well, eventually, we run out of IP addresses, and we need to reissue a new IP address. And so we use that IP address that we had from Joe Schmo at the coffee shop. It takes that IP address. He was here on Monday. Well, now it's Thursday. That IP address can be issued to a new device. Okay, it's called an IP lease. Okay, so if it's your IP addresses the leases are expiring, they're available for someone else to use. Well, in an NDI network, okay, especially if you're, we'll talk about this in a minute, but if you're isolating the network, you're probably not going to have a bunch of devices joining the network and needing to use the IP addresses that were issued to your cameras. Matter of fact, for an NDI network, less traffic is desired. And so if you have an isolated network, let's say we have a VLAN network that is just for your AV stuff, okay, and you don't have a bunch of devices that are joining off and on again, the DHCP will actually remember your MAC address and reissue that same IP address every time it joins. So say I walk into my studio and I power everything on, I turn on my switch, all my cameras come on in the VLAN. Well, the switch knows, well, this camera had like 192.168.1.115 last time, so I'm just going to give it that address this time. In this scenario, here's another little pro tip, and this is why you tune into the show at birddogjohn.tv. In this scenario, if you do get new IP addresses, typically it indicates that something is wrong with the network because it thinks for some reason that everybody needs new IP addresses, and it issues new ones. And so you could have a leasing problem inside the DHCP service. It may just not be configured correctly. You need to have a longer lease time. Anyways, pro tip, there you go. So in the DHCP configuration, if you don't have a lot of devices joining the network, your devices will get the same address kind of by default. Now, there is a chance that they might change, but by default, generally they get the same address, which is super convenient because, you know, then you can link decoders to cameras or to your vMix system or whatever, and it'll all relatively stay the same and continue to work. There is a feature inside DHCP, and many of you know where I'm going with this. There is a feature, however, inside DHCP services called the DHCP reservation list or the white list. It's less and less called white list now. It's called reservation list. But it's a service that's hosted inside the DHCP services that reserve an IP address for a specific MAC address. So one of the common cases we get for static IP addresses is, I don't want my IP addresses to change or there to be a risk that it will change. And the answer to this is, okay, but you're losing all the intelligence of the DHCP routing by just going straight up static. And so a DHCP service will enable all the routing, but you can also go inside the DHCP service. Any DHCP worth its salt, any routing service worth its salt will have this option. And you can list, I want this MAC address to be associated with this IP address. So now we can take 192.168.1.10 through 21 and put our devices, you know, our 12 devices in this instance, on the same IP addresses all the time. So now when the device gets plugged into your NDI network, and you can do this on any, you know, configuration, by the way, now what will happen is when the device comes online, the device will say, hey, I'm in DHCP mode. I need an IP address. It knows nothing of the reservation list, by the way. It just says, I need an IP. Here's my MAC address. And the DHCP will get the list and say, oh, hang on, this is on my reservation list. And they're supposed to get 192.168.1.12. And so it'll say, here you go, your address is 1.12. And the camera says, great, thanks, 1.12. Now, what's happened is that when the camera comes online, the system knows that camera always needs to have this same IP address. The system will also operate with a revolving DHCP lease time, but it will never issue 1.12 to anybody else because you have it on a reservation list. It's on a list that is reserved for a specific MAC, which means that then you can have people coming and going and joining your Wi-Fi and asking for IP addresses. Those devices will never get an IP address that's on the reservation list. That's the point, which means that you gain all the functionality of the DHCP routing, okay, which is really important. MDNS is a big deal in NDI. And you need to hear me say that again. MDNS is a big deal, especially for control. It's a huge deal. You need it. It's enabled in the DHCP configuration, and it's sometimes is and sometimes isn't in static. That's up for debate. You need it for NDI. You need MDNS for NDI. So using a DHCP configuration gives you all that routing stuff, and it gives you the flexibility to reserve IP addresses for certain devices. Now, it'll be different per manufacturer. It's different for Netgear as it is for Cisco, as it is for Unify, as it is for so-and-so. Like Unify, for example, doesn't call it a reservation list. It calls it a fixed IP. And so you go into the device and you say, make this a fixed IP, and you're adding it to the DHCP reservation list is what you're doing. So for those of you who have Unify networks, you go to Devices, You click on the device from the list. It opens up that little side menu right in the web UI. Scroll down to network and click on fixed IP, and you can give it a fixed IP. What will happen then is Unify will never issue that IP to anybody but that MAC address. It's really an ingenious way to keep things stable, and that way you know. Then you can have your spreadsheet, and you can say, okay, and on my spreadsheet, I want to know what those IP addresses are, and so then you can list them out. Here's the other thing that's beautiful about this. It's a centralized management system, okay? You don't have to log into every web UI now to figure out how to configure that network node. It's all in one place. It's on the DHCP service. So it's on the router, or it's inside the web UI, or it's on the Unify interface, you know, or the portal interface, whatever it is that your network interface is, it's all there in one place. And you can make changes to it, by the way, in that one place. You don't have to go to every single web UI to do it. This is a huge advantage when you're talking about managing a larger infrastructure. You want a centralized managed system. Get familiar with the network interface that you're using, and utilizing DHCP reservations will allow you to always manage the IP information for your network nodes. It means that you don't have to go and touch the devices. You can do it all in one location. And, oh, by the way, if you're servicing clients, if you have clients that you're managing the network for, now you can do most of this remotely. You can do all the networking stuff remotely. You don't have to go on site. I mean, it might be nice to show your face to your customer every once in a while, but you don't have to go on site if they're having a problem. You can log on. Okay, you can look at the reservation list. Yes, nothing has changed here. This camera should still have this IP address, but it's not coming up on that IP address. It's falling back to 100. Maybe we've got a botched update or something like that, something wrong. You can assess things much quicker than if you are monkeying around with the actual static settings inside the camera. Now, pro tip. I need like a pro tip sound effect. Now, pro tip. It's also, in terms of workflow, consider this. It's not advisable from a support standpoint to change the fallback IP address. Okay, I know you can, but it's advisable not to do that. Don't change it from 100, and here's why. When you see a 100 address, you know something's wrong. Okay? 100 should be a unique identifier for you. And we do that because, 192.168.100 is kind of an odd, I mean, it's an even, but it's an odd number. And it should appear on your network or on the screen. Like if you got decoders and if you got a BirdDog plane, it shows up as 100, you know that thing didn't get an IP address from the DHCP. Right? It's one of those unique things that when you see that information, you know something's wrong with that device. Something's wrong. So I would strongly advise you, as a pro tip, to not change the fallback address. And the exception to this is that if you set that fallback address to something within your IP range. Now, a secondary pro tip here in the DHCP configuration is well, anyways, a second configuration or a second consideration that you should use is not using the 100 subnet as your DHCP configuration. Again, it should be unique. So here in my office, I use a variety of ranges. I have a network that's 192.168.1 dot, a WAC24, so I got 254 addresses there. Then I have a 192.168.85 desk, okay, and that is those are my repair technicians. Actually, those are my ticketing agents, and so the ticketing agents have their own isolated VLAN, and they're able to, they know when a device gets an 85 address, the DHCP function of the device is working because they have a unique one outside of my bigger infrastructure, the one network. And then my inspections technician, okay, Balu, he has a bench, a tech bench, and his is 192.168.3 dot, WAC24. So he knows that when he gets a device in from a customer and he plugs it in and it gets a 3 address, okay, the network function is working correctly. All right, so those unique identifiers. Now, notice that none of those networks are 192.168.100. Because when we get a 100 address in this office, we know something is wrong on the device itself. And so the idea here, the thought process on the networking scheme of things is make it unique to you. Pick your favorite number between 1 and 250, okay? You get to pick any of those. You're going to make a WAC24 network that's going to give you 254 usable IP addresses. But pick your favorite number. Just don't let it be 100. If 100 is your favorite number, pick something else. Make it your lucky number or make it an unlucky number. I don't know what you want to do. Just don't pick 100. So 192.168 something dot, pick your favorite number between 1 and 250 dot, and then make a WAC24 network. That will give you 254 usable IP addresses. And the reason why I say WAC24, and we're kind of getting into the nitty gritty here, is because if you're operating more than like 20, 30 devices on an NDI network, we're already talking about multicast, which is different. That's not a unicast network. And the DHCP function right now, we're kind of leaning on the unicast environment, the TCP RUDP environment. So if you're functioning in this way and you're thinking about, I want to revamp my NDI network. I got these 4250s. I'm going to VLAN them off, and we're going to make our own little isolated DHCP network, which, by the way, the 4250 and 4300 line from Netgear are layer 3 switches, meaning that they can run DHCP services on the switch themselves. It's genius. So, oh man, $700 seems like a lot of money for a switch. Yes, but it could also be a router. It's also going to be the brains of your operation. And so $700 to make sure everything works perfectly well, it's actually a great investment. And you have to think of it that way. I'm going to invest this money here up front so that I'm not investing my time and energy and resources later on troubleshooting a crappy network. Okay? So invest in quality equipment. And I can't speak highly enough of the 4250s, mostly because Netgear supports NDI. They actually are designing profiles and updating profiles for the NDI 4 and 5 protocol. And so we'll talk about that briefly here as well. But it's a centralized place. Layer 3 4250s will give you the ability to do VLANing on whatever ports you're using. And it's a great way to manage, troubleshoot, remote in and help your customers. They'll love it because they don't need a coordinated time for you to come out on the site. You can just remote in on the computer when they're there at their convenience. It means that you don't have to drive out there and waste your time doing that. You don't have to worry about, you can still bill them for the time because you're remoting in and working for them, right? But it means that you don't have to do all that travel and overhead. It also, by the way, might expand, if you're in this for a business, might expand your territory. Because now most of your work is done remotely, which means you don't have to drive to the next state to do the troubleshooting. You can just remote in and find out what's going on. And it's like, yes, that unit's, having a problem. Let's coordinate with BirdDog to get that thing inspected. Or you can ship it to me. Here's a shipping label. Saves you all those hours in the car, right? Saves you all that time. You can start thinking about your business, your integration business as, oh, my territory could now go to like the surrounding states or provinces or countries, because now I don't have to travel as much to get this job done. I just have to go there to install it on site. I set up my little remote system, and then I can leave. Unify is great for that, by the way, because you can put cloud keys on a Unify system, and then you can see it. Now, I'm not recommending Unify for NDI necessarily, but if you want to use the gateway and the cloud key as the way that you remote into the system, that's a thing. That's a thing. Anyways, we won't get into how to run your business. We're going to talk about why you and how you would use DHCP service. So the case for DHCP is it's actually way easier. Once you have it up and running, it's way easier to troubleshoot. It's much more consistent. And here's an added bonus that may go unnoticed. An added bonus to a DHCP system is all of the devices that are on the network are running in DHCP, meaning the customer says, hey, we have 3 cameras in our church auditorium. I want to take one of those over to the youth room, which is not on the NDI network, and I want to plug it in, and I want to plug in OBS. Will it work? You can say yes, because you don't have to go in and reconfigure the camera to be on the new network. If the youth room is on a DHCP, he can just unplug the DHCP-enabled camera, take it to the new location, plug it in, and guess what? It gets a new IP address because it's going to broadcast, hey, I'm new to the network. I need an IP address. And the DHCP on that network will say, great, you're going to be 192.168.77.3. And the camera says, perfect. And then when they're done their event in the youth room and they take the camera and they put it back in the sanctuary and they plug it in, guess what? The camera's going to say, hey, I'm new to this network. This is my MAC address. I need an IP. And the DHCP is going to go, great. Oh, this one's on my reservation list. He needs to have 1.12. And he's going to be reissued the same IP address that you told it to reissue when you installed everything. Which means that if you have things that are decoding like vMix, or you have sources that are looking at that IP address for that NDI source, it's not going to break the system. Okay? So DHCP is your friend. It's very flexible. It gives you much more ability to allow your customers to be a little bit more creative with the way that they're using the equipment. It means you don't have to go out every single time they want to move a camera. It also means, for example, your customer is going to come to you and say, you know, we love NDI. We love these cameras. We want to buy 2 more. And you say, cool, let me order those for you. You get them shipped to your shop or your home location or whatever, and you take those MAC addresses and you remote into their system. And the MAC addresses from those cameras, you punch them into the DHCP reservation list before those cameras arrive. And you assign them 1.15, 1.16. Then you ship them out to the customer. You say, here they are. Plug them into your NDI network. They plug them into the switch. They start booting up. And guess what? They say, hey, we're new to the network. We need an IP address. And the DHCP reservation list says, oh, they're already in here. They need to get 15 and 16. And so the IP addresses get issued. The camera's none the wiser. It thinks that the DHCP router is some sort of wizard, but you've already done the customization behind the scene. And guess what? Now every time those cameras power on, they're always going to get the same IP addresses. So this stabilizes the network. It maximizes the DHCP routing capabilities, but it also increases the smart level of the network, as it is going to act as a DHCP system, but it's going to issue specific IP addresses to each of the devices that you've indicated, which means you can have your little reference, press this little reference Excel sheet that tells you on this client, on this network, this is the way that it's configured. We do this all in DHCP reservations. If they have a networking issue, you can remote in and see, yes, you know, there's something going on with the DHCP service. For some reason, it issued the wrong IP address. Let's reboot that device and see if it gets the one from the IP reservation list. It's a great tool to stabilize networks. And I think it completely waters down the argument that the reason why we do static networks is because we want to know the IP address of the device. It basically makes that caveat moot at this point, because you can do that with DHCP. And it's actually a lot better in terms of it enables all the DHCP routing. So DHCP gives us the ability to route data. The network is self-aware of where that data is going. It keeps routing tables up to date on its own, okay? It keeps an MDNS record, which is required for PTZ movement, for example, when you're running on keyboard especially, but in general, an MDNS is required. Remember in the static video, I don't know if you've seen that one yet, we talk heavily about Discovery Server, which is the replacement for an MDNS on a static network, because most static networks just don't have a genuine MDNS that's being actively updated. Sometimes there is one, sometimes there isn't. But MDNS is critical for keyboard use, for pan tilt zoom movements. A great example of this is if your MDNS is malfunctioning or you don't have one, the stop commands from static from your keyboard or from Studio Monitor won't make it to the device occasionally, and you'll notice your camera just keeps moving in the direction you were moving it. You let go, it snaps to 0. There is a packet that goes out that has a stop command that goes to the camera, and if you don't have an MDNS, there's a good chance that packet's not going to make it. And if it doesn't make it, the camera keeps moving after you've told it to stop. Okay? So MDNS is critical, and DHCP gives you an MDNS without you really needing to configure anything at all. Okay, so now I want to talk about configuration. I want to show you how to do this inside of VLAN on, we're going to use a 4250, actually the one that's right here in my office that's sitting in a little pseudo rack next to me that governs all my cameras. So I've got a P100, I've got a P4K, I've got a P200, and I got a P110. Okay, I've got four cameras in the network. Plus, I've got screen shares and I've got a whole bunch of stuff happening over NDI. I want to show you how to do this. And I have videos, by the way, tutorials that walk you through the 4250 installations. I'm not expecting you to use this video for that. If you want, go to the BirdDog Australia website, and I'll put them over on my site too. But go to the BirdDog Australia website, a YouTube page, and look for the playlist called M4350 and BirdDog. There's 5 videos there that will get you started from out of the box switch to fully functioning NDI network. That's for you, free of charge. There you go. That's why we do that video. So, and I've been told on a couple of occasions, including last Tuesday, that somebody used it to set up their network and everything's humming along. So, good times, great oldies. Okay, let's go over to my switch. And I just want to show you what I've got going on. Now, I've done some things to this switch. You know, I've set it up and it's been running for 30 days, for example, without a reboot. So there is a lot going on here. But you'll also notice I don't have a VLAN particularly for this studio, which I could do. However, I use these sources for other things inside the one network. So I don't have a VLAN set up for this one, but I will show you how to set up a VLAN and how to actually do all this with DHCP. You want to configure your own profile, and you can see here that there are profiles throughout my office that have their own configurations, right? So these are VLANs. So for example, my ticketing agents have a test bench, and their network is known as the 85. And so the DHCP for that is 85. That's the DHCP range. I also have a VLAN that was set up for this studio. It's called Studio 77. So inside there, we have a range for 77. The default gateway that I've gotten, okay, is 1.60. That's the address of this switch, is 1.60. And you can assign that address to a specific port. But basically, when the network comes into the system, that is the interface for this switch. So if I want to get there, you'll notice up here at the top, I've typed in 192.168.1.60 and hit enter, and it takes me to the web login page, okay? Now, that is a reserved address on my DHCP, so that this switch will always have 1.60. So I know. I can actually even label the switch if I want, because I know that when this switch powers up, it's going to say, hey, I'm new to the network. I need an IP address. We're going to look at that reservation list and say, oh, that is that MAC address, and it needs to have this IP address. So DHCP reservation happening right there, real deal, okay? That's how you could utilize it. Okay, I've got multiple switches and multiple devices. I don't want their IP addresses to be changing, but I want the advantages of DHCP routing. So we'd add all of those items to the reservation list. Make it something obvious, 1.60. You know, that's an obvious number. My other ones, for example, though, I didn't do 1.116, but I know that one from memory because it's my network. So make it something obvious. Make it something easy. All of your switches are on the 10s. Okay, so you have a switch and it's 1.10 and then 1.20 and then 1.30. So you know switch 1 is 1.10, switch 2 is 1.20, switch 3 is 1.30, right? Easy. And then the devices that are on there can be in that range. So it's an 8-port switch, so we're not going to run out of IP addresses. So things that are devices, cameras that are plugged into switch 1 on the 1.10 switch are going to be 1.11, 1.12, 1.13. Map it out logically so that you know when I plug this thing in, it's going to get a 1.11 address because it goes into switch 10, okay? So there are ways to think about it that can be extremely helpful. All right. Now, let's get into one of these profiles and figure out how to do this. So on the 4250's desktop, on the web UI, we're going to click on Network Profiles. And it's going to give us the option to basically create a new one. Okay, we can create, wait, is it behind this? Is it, what's going on here? That's strange. Let's refresh this page because it's showing me the bubble for some reason. Edit the default program. Okay, well, whatever. So we can create a new little profile, and we do that down here under Profile Templates. Now, depending on what you're doing, right, you can isolate your Dante network from your NDI network by creating 2 VLANs. All right. So we could go down to video, right here, and we could say, okay, I want to do video with Dante audio. And so this is going to be like your standard out of the box Dante stuff. So we could create a profile for the ports on the switch that are just for Dante. And then we could go over here. We could say video NDI 5. It says, well, with Dante. Well, I want to keep my Dante and my NDI 5 separate. So I'm going to create a separate VLAN that's going to be for just my NDI 5 devices or my BirdDog devices, okay? So you click on the little cog wheel, and it's going to ask you some general questions. Now, the first thing is going to say which ports on this switch are going to belong to this VLAN. Now, larger network installations use the same configuration across all their switches. So if we were going to do a half and half Dante and NDI switching ability, well, I would say ports 1 through 4 are NDI, ports 5 through 8 are going to be Dante. Okay, those are my PoE ports on this switch. Ports 1 through 4 are NDI, and ports 5 through 8 are going to be my Dante network. Now, it doesn't have to be in that order, but order is helpful in this instance. So we can say we're going to select, 1 through 4 are going to be a part of this VLAN that I'm going to create. And it would then start governing these ports when I hit apply or save. It would select those 4 to belong to this VLAN. Now, if I have 20 switches, okay, when you plan this all out, if I have 20 switches, it's helpful to have the same configuration on every single one. Why? Because then anywhere in your operation, on any switch in your installation, ports 1 through 4 are NDI, ports 5 through 8 are going to be your Dante network. Or maybe you don't need that many Dante channels. So 1 through 6 are going to be your NDI networks, and 7 and 8 are going to be your Dante channels. That way, when you roll up on any Dropbox, on any headroom, if you go into any sort of server, chassis, anytime you look at your AV network, it's the same configuration on every switch. All right. We do this in the NDI realm we do this in the networking realm because it makes a universal understanding through your entire organization. Maybe you have multiple people interacting with the network. Maybe you have you and 6 other technicians. The mantra is these ports are on NDI and these ports are going to be used for Dante or for our data VLAN. So in this scenario, for example, my data VLAN is VLAN 1. So the one network, right? So 192.168.1. Anything with that one network is my data network. And those ports are 9 and 10 because 9 and 10 are non-PoE ports. And traditionally, I would plug a computer into that port. And I need data. I need to get out to, StreamYard, or I need to do whatever. 9 and 10 are my data networks. And then 11 and 12, which are being utilized, by the way, go to either your network trunk, or you could patch them into a fiber port that's plugged into your beefy computer, which is what I'm doing right now. I've got 2 dual fiber SFP to LC connections going to that switch, which is giving me 2 gigs back to my NDI network, which means that NDI will load balance, which we'll talk about in another show. It'll load balance, but I can get all this data into my computer over 2 1 gig fiber connections. So it's lightning fast. So the 4250, this is the way that you think about delegating VLAN ports that you want to use in a fleet. Steer clear. Do your best. Okay, pro tip right here. Do your best to not configure every switch uniquely. Because what that's going to do is create a lot of confusion when it comes time to support it. Okay, you need to, for a lack of a better word, unify the network. Okay, not ubiquity, but you need to have a unison configuration for your switches. And you might think, well, I've only got 2 switches and I need 2 cameras here and I need 8 cameras over there. Okay, you need to think a little more about scaling. Maybe buy an extra switch or 2 so that you can put 2 switches in the location, and ports 1 through 4 are your NDI on both of those switches. By the way, load balancing switches is ideal because these switches have processing power. And that's going to be your bottleneck if you front load one switch with a bunch of NDI encodes, or decodes for that matter. If you front load one and you're light on another, that one switch is going to be working like a dog. And you don't really want to overload the processor on the switch because you're going to get dropped frames. Okay, you're going to start filling up the packet buffer and it's going to start dumping stuff. So more is better, and using the same configuration across all your fleets. That's good practice. It's good networking practice. If you want to impress your networking friends, have a unified VLAN configuration throughout your entire fleet. Now, a word about VLANs. VLANs are designed to be isolation or islands in the networking world. They operate on their own. Inner VLAN traffic is a big no-no. As a networking person, as an NDI user, you should not be making inner VLAN traffic a common practice, and I'll tell you why. The nature of VLANs is to separate traffic, and literally at the packet level, okay, I say literally because it actually is literally at the packet level, there are VLAN identifiers in the actual bit sequence. Okay, so if you take a Networking Plus course, they talk a lot about this, but basically the packet comes in, and inside that sequence, there is a VLAN identifier. And what that identifier does is it tells other packets and the greater network infrastructure, this packet cannot interact with packets with other VLAN identifiers. Now, all networks are already operating on a general VLAN, VLAN 1. Okay, that's a broad, it's a non-VLAN VLAN. Okay, it's basically everybody gets put in the same pool. But when you start adding other VLANs, then the VLAN with your new VLAN tag cannot interact with VLAN 1. That's the point. The point is to isolate. So when we talk about turning on VLANs for NDI traffic, you also need to consider then your computer is going to have to be a part of that same VLAN, which means that in this configuration, back to the screen, if 1 through 4 was going to be in my new VLAN for my NDI network, but I was going to plug my computer into VLAN 9, or I'm sorry, into port 9, I might want to add that port to the same VLAN so that one port on this computer will go to port 9 on my switch and join the NDI network, and then one port on my computer will join port 10, which is on the data network, which means that this computer will get 2 IP addresses, one from the VLAN for the NDI and one from the data network, right, internet. So we can have an isolated NDI network and we can have an internet network. The computer can belong to both, which means that we can stream to the internet but interact with the NDI streams. And so in this configuration, we might want to add 1 through 4 and port 9 on our entire list, as that is a non-PoE port that belongs to the NDI network. Okay, so we don't have to sacrifice. Now, of course, you could plug the computer into ports 1 through 4. Maybe you're not using all 4 on the switch, so you can plug it into port 4 and you're off to the races. But you waste that port that has PoE potential, right? My computer doesn't need PoE. So instead, I plug it into port 9 and I join it to that VLAN. So now in my configuration across my entire fleet, I have 4 PoE ports for NDI and 1 that non-PoE port for NDI. Okay, so the configuration would be 1 through 4 plus 9. Okay. I hope this is as riveting as you expected it to be. All right, so we want to make a VLAN. Now, I'm not going to configure this switch live on the stream. I will make this VLAN, but I'm not going to join any ports because that will probably butcher my actual recording here. So let's not do that. But here we want to give this a profile name. So I want to give this here a name. So I could say like BirdDog Studio, US Studio, because we actually have a recording studio in Melbourne. US Studio. And what I like to do is in the profile name, tell it the VLAN number that you're going to use. So I really like the number 7. So I'm going to use VLAN 70 as my identifier. So the name is BirdDog US Studio and then underscore. Okay, it's all one word, underscore 70. And then it says, give me the VLAN identifier. So the ID would be 70, 70. So I know that when I belong to the 70 network, I'm on the correct NDI VLAN. And then just for funsies, you can select a color on the 4250, so blue. Why not? And it will actually turn those ports blue when you've applied it. So blue is going to be that. Now, you could just hit done, and you could be done. However, I want this to be DHCP enabled, right? Because we want our devices on this VLAN to get a proper address. So we're going to turn this on, and we're going to change this to, to static. Sorry. change this to static. Now, this is the question. Remember back on the initial screen for the dashboard, I said 1.60 is what my IP address is for this switch. This box, VLAN IP address, is what is the IP address for this switch in this VLAN. Okay? In other words, what is the gateway for this VLAN? Okay? So 192.168.70. Okay, I'm going to use the VLAN number in this instance as my identifier octet. So 70 is the one that I want. I want everybody to get a 70 address. So when the camera comes online, it says I'm at 192.168.70.1 or 70.2. I know I've joined this NDI network properly. All right, so 70.1, or you can use 254 is also a very common gateway. All right, so 1 or 254. Subnet mask. Say it with me now. 22255, 255, 255, 255.0. This is a WAC 24 network, meaning that I'm going to have 254 usable IP addresses, 56 if you want to be technical, but 54 usable addresses. 254 because in 70.1 is taken and 256 is going to be taken. And so 254 usable addresses. So from 2 all the way to 255. All right. So 254 usable addresses. And then I want to turn on my DHCP server. Now, the default router, right, the IP address for this switch is .1. So that one's used, right? And then it says, what is the range that you want me to issue IP addresses? Now, I like to use this to my advantage. I want to reserve certain amount of addresses that I could use if I need to statically address something. Okay, if I need to break my rules, I need to have a handful of addresses that will never get issued on this network. So I like to start at 10. And I say 192.168.70.10 is the first address that you should issue on this network when someone asks for one. And I want this to go to basically 200. I'm not going to need more than 240 addresses ever on my NDI network because I'm going to be changing it to multicast if I do. So 200, 250, that's fine, okay? You can set it to whatever you'd like, but it needs to be within 254. All right, so don't go more than 254 because that will break. Actually, I don't think you can. If you say 70, yeah, it says, yeah, no, that's too many IP addresses for a WAC 24. Don't do that. So in this instance, let's say 250, and it says okay. Now you can set, if you are setting up internet, you can set a DNS record for this as an actual server. I won't go into that here because we're making an isolated non-internet based VLAN, okay? But that gets into that. And then, these are empty. These are search domain is empty. The last piece is the least time. So this is in minutes. All right, think of it as minutes. And so if we were to pull up our trusty dusty calculator, right, and you say 250 divided by 60, that's 4 hours. A DHCP will hold on to a license for 4 hours. Now, we can make this whatever we want. All right, so maybe I want this to be like 4 days or something like that, right? Well, all you have to do, or like a week. So we want to make it 7 days. Well, 7, whoops, sorry. Let's just do this. 7 days times 24 hours, right, is 168 hours. And then 168 hours times 60 minutes is 10,080. So we can set this, I believe, to that limit, which is 1 week. All right. Set the time. I have a 1 week limit on anybody that joins the network that I haven't put in the reservation list. This is how long I want them to keep the address. Okay. And now we've gone top to bottom. That's everything on here, and things will start getting issued an IP address. If I hit apply, it says we really recommend that you use one DNS server. We're not using this for internet. And so I'm going to hit apply. Now, I didn't select any of the ports on the switch, right? And so it created the VLAN, but it did not make any of my ports belong to that VLAN. All right. This is extreme. So when you build VLANs, and if you have multiple switches, you need to build these VLANs inside of each of the switches so they know that the VLANs exist. But once you do this, then, and by the way, you can do this on one switch and export this configuration and then import it on all of your other switches. So thumbs up to Netgear for making it super simple for you. But you can export the configuration. I believe it's under maintenance. And yeah, download configuration. And you can upload that configuration to other switches and then just make each of the switches unique. All right. But you can do that and make it super easy for you to have the same configuration across all fleets. So you set up all your network profiles, you download that configuration, and then you upload that to all of them, and that should be how that works. Okay, so now any port that I add to the VLAN, okay, so I go into the VLAN configuration. Now, how do I do that? I click on this and I say Edit, and I select the ports that I want to add to that VLAN. When I do this and hit Apply, it will add those 4 ports to that VLAN. And then when I plug a device in and it powers up, it's going to ask for an IP address, and it will get a .70 address. And if I look at the web UI, or if I go to Studio Monitor, I see that camera, right? I've joined my computer to that VLAN. Remember, it's isolated. VLANs are isolation. That's the whole point. So if you're on the one network, you will not see the 70 network. You need to join your computer to that VLAN, open Studio Monitor, find that camera in Studio Monitor, and go to the little cog wheel, go to the web UI, and it should say 70.2 or 70.11 in this instance, or .10, wherever the pool started. That's how you know you've got it set up correctly. Now, I won't get into DHCP reservations in this one. I'm advocating that now I have all of the brains, all the routing information, the MDNS. I've got a smart network that can cross VLANs. If you trunk these switches together, for example, on these ports, you can even trunk on copper if you want. If you trunk them together so that they're all talking together on the same pipe, the VLAN information passes through a trunk unbeknownst. It's not processed. It's just a trunk passes all VLAN information. So now all VLANs on all switches that have the same VLAN configuration will talk to all devices within that own VLAN. Isolated. They won't communicate. They won't interfere. Okay? And the services that are running for the 70 VLAN will not inspect packets on the 1 and vice versa. Okay? So you optimize your performance. That goes up. So VLANing your NDI network is incredibly efficient. It isolates the traffic. You can even, if you want, prioritize a VLAN over another one. So say I want the NDI VLAN to take priority because I want those packets to be processed before any of the data stuff. You can prioritize a VLAN. So .70 is high priority compared to the data, which means that those packets get processed before the other ones. So if there's ever a backup, it won't be happening on your NDI network unless you've severely overloaded the switch. All right. I am going to wrap up the DHCP discussion there. I think I've advocated that it is a desirable way to design your network. It also provides you the ability to kind of recap, provides you the ability to manage your network remotely, manage it and simplify it. If you utilize DHCP reservation lists, your IP addresses won't change, and you can go into that list and see what the configuration is. And the beautiful thing about using an AV switch that supports NDI is their support team also supports NDI, which means that you can reach out to Netgear or to other AV line switches and ask for help. We are very familiar with them here at BirdDog. And so configuring a switch in DHCP to be self-governed, to provide you with all the routing tables that static networks don't do, to give you MDNS, which doesn't work very well in a static environment, so you don't have to use Discovery Server if you don't want to or have to. That's also an advantage of having an active MDNS, an updated routing table. All of those elements are available if you follow the instructions to just set up a simple DHCP VLAN and plug in your devices and have them operate on that level. Like I said at the beginning, since I'm not going to be bringing on lots of devices that are going to be asking for IP addresses in an isolated VLAN AV network, the lease might expire, 7 days, might expire, but the switch will still remember the MAC address. And modern day networks, more than likely, the device, even if the lease is expired, the device will be given the same IP address that it had prior, because there has been no need to reissue that IP address for another device on the network. So the level of learning and knowledge, I mean, that wasn't too scary, right? Watching that process, that wasn't too scary. But the level of learning that's required to make your life exponentially easier, okay, by running DHCP over static, your quality of life will improve. Your customers' reliance on their NDI network, that will be elevated to a new level of reliability, and you'll probably be getting a whole lot less calls than if you were running it in a different configuration. So I can't speak highly enough of it enough. Netgear make it super simple for us to do this. You know, they've taken the time to really hash it out and make sure that it adheres to NewTek and NDI standards. They've worked with BirdDog directly. They help us configure our own stuff, and I can't speak any more highly about it. So definitely check that out if you're looking for a seamless network NDI experience. All right, we're going to go back to the chat and see what's going on over there.